So the first thing that we're going to do is pull up our outline. And if you'll notice on my outline, I tell you to pause the video as you go through this outline. So what you're going to do is you're going to be watching this video and you're going to pause things and you're going to work through problems as you go to make sure you understand what's going on. Your homework problems will also be listed on this outline. So the first thing that the outline does is it tells you to read page 176, and we're specifically looking at this definition of a ratio, and it says a ratio expresses a size relationship between two sets and is defined as a quotient of two numbers. Now quotient just means division, so we're really just looking at fractions. It is written using the word to, a colon, or a fraction. That is, if the ratio of men to women is 5:4, this could also be written as 5:4 or 5/4 as a fraction. We will emphasize the idea that a ratio can be written as a fraction or as a quotient of two numbers. Since a fraction can be reduced, a ratio can also be reduced. So we're going to make sure that we reduce those ratios. Now, I also say on the outline, I say work through example 1 and make sure you can use your calculator. So that's the first thing that we're going to do. We're going to work through this example 1, and I'll work through it, and then you should pause the video and make sure that you understand it. So let's take a look at that first. So let's just look at this example 1. It says, reduce the given ratios to lowest terms. So when we're taking a look at this, we've got 4 to 52. And what we want to do is turn it into a fraction. And then we just want to reduce it. And if you remember reducing fractions, you pick a number that will go into both of them. So I know that 2 will go into 4, and it'll go twice. And 2 will go into 52 26 times. So this is what we have so far. And then 2 will go into both of those again. So we have a 1 to 13 ratio. Now, if I take a look at the calculator, this is the calculator that I've recommended for you guys. And if I take a look at this one, we go over here. This is the TI-30XS calculator. So this is the one that I've recommended. It's the one listed in the syllabus. And we take the first number and we punch it in, so 4. The fraction key is in the third row. And then we type the second number in. And when you hit enter on the calculator, it reduces it for you. So it comes up to 1/13. So it's going to do that for every one of them. So even if we're doing one that's a mixed number, so like let's say we were doing example 1 part C, and it says 1.5 to 2. If you notice on your calculator, there is a green button up above the regular fraction button, so in the third row. So I want to do a mixed number, so I access that by hitting the second and the fraction, and I type in my mixed number in the fraction template. So 1 1/2. So again, this is part C. So there's my fraction 1 1/2. And then over 2. So I can hit the divided by if I want to, or I could just hit the fraction. I'm going to hit enter. And notice it reduces it for you. So it reduces it down to 3/4. So that's what you're doing on those. You're just reducing them down to lowest terms, and it does it for you. So if you look at your outline, it says work through example 1 and make sure you can use your calculator. So that's what I've done here on this particular calculator. And again, this is the one that I recommend in the syllabus. It's about $12 at Walmart. It's the TI-30XS. So work through that example on page 176 and make sure that you can use your calculator and that you get all the correct answers. The next thing that's on your list says read the definition of proportion on page 177. So let's go back to our book. Page 177 will be the next page. And it says a proportion is a statement of equality between ratios. So you're going to have two ratios and they need to be equal to each other. So if I look at a proportion and I want to make sure that they're equal to each other, I can use the property of proportions, which is on page 178, and it says if the product of the means equals the product of the extremes, then the ratios form a proportion. So if I take a look at two proportions, like or one proportion, which is made up of two ratios, and I'm looking at example 3. It says, tell whether each pair of ratios forms a proportion, and it has 3/4 and it has 36/48. So what you're going to do is you're going to take the top number on the left and multiply it by the bottom number on the right, and then the same thing with the bottom number on the left and the top number on the right. And if those two things come out equal, then it is a proportion. So we're going to take 3 times 48, and we get 144. And we're going to take 4 times 36, and we get 144. So this is a proportion. So yes, it is a proportion. If, when you multiply those two, they come out and they're not equal, then they're not a proportion. So like on part B, again, this is page 178, example 3, 5/16 and 7/22. When I multiply, 5 times 22 is 110, and 16 times 7 is 112. So those two things are not equal, so no, this is not a proportion. So that's what you're looking at for the property of proportions. And on your outline it says to make sure that you can work through example 3. And again, that's on page 178. So for this section, the only thing that you're doing is you're doing section 4.1, and at the bottom of your outline it says do some of the problems and check the answers with the back of your book on page 179, 31 through 45. So what I did is I went to that page, and we're going to just work through a couple of those. If I look at number 31, it says tell whether each pair of ratios forms a proportion. So you're going to do what we just did. So this is number 31, and you're going to take those two ratios and you're going to say 6 times 12 and 9 times 8, and if the two numbers are equal, you're going to say yes, it is a proportion. That's all you're doing on that section. When you get to the next part that I've assigned in 51 through 59, it says a baseball player's batting average is the ratio of hits to times at bat. For example, how many hits per times at bat does a player with a batting average of .275 have? And it does 0.275 over 1,000, and it reduces it down to 11/40. So we're going to start with number 51, and we're going to go through 59. So I'm going to look at number 52, since you have the answers to the odd ones. So number 52 on page 180 says, a cement mixture calls for 60 pounds of cement for 3 gallons of water. What is the ratio of cement to water? So we have 60 pounds, and we have 3 gallons. So when I reduce that, if I put it in my calculator and I do 60 divided by 3, I get 20. And since this is a ratio, you need to have two numbers. So we say this is 20 pounds of cement per 1 gallon of water. And that's what it's asking you to do. If you look at part B, it says what is the ratio of water to cement. Notice that the water's on the top this time. The water's the first one you come to. So you would say 3 gallons to 60 pounds. And you would reduce. And you would have 1 gallon to 20 pounds. So this is what this section is asking you to do. So that's your practice for that section. Now you will also end up having a web assignment, so look for that in your lesson.